Hey guys, tonight we stand at the strangest doorway you can imagine. A place before stars, before planets, before your room, your pillow, your slow, blinking charger light, before the Milky Way ever learned how to turn in the dark, before there was even a proper meaning for the word before. You are surrounded by darkness, but not the normal kind. Not a dark bedroom, not a moonless street. This is deeper than that. There is no room yet, no sky yet, no distance. No clock, no quiet world continuing somewhere else. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And tell me your location and local time in the comments, because I always love seeing where in the world people are listening from. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. The most relaxing fact about the birth of the universe is that it did not begin like a scene from a disaster movie. No giant fireball bursting through space. No cosmic alarm vez. No dramatic narrator shouting like reality had just made a terrible decision. The beginning was far stranger and, in its own way, much calmer than that. The universe did not explode into empty space. Space itself was part of the beginning. Time was part of the beginning too. The stage, the distance between things, the possibility of change, all of it arrived together. That alone is such a beautiful idea. The universe was not born inside a bigger room. There was no empty black hole waiting for it to appear. No Aegis, no outside wall, no cosmic landlord handing over the keys. When scientists talk about the Big Bang, they're not talking about an explosion happening at one point inside an already existing emptiness. They mean that the universe itself began in an incredibly hot, dense state and then started expanding. Everywhere was involved because everywhere was all there was. The name Big Bang is honestly a little misleading. It sounds loud. It sounds messy. It sounds like the kind of thing that would leave a huge crater and a paperwork problem. But the real picture is subtler. It is not that matter flew out through space from one central point. It is that space itself expanded. The distances between places grew. The universe was not moving into something else. The universe was creating the something else. And this is where your mind starts doing what every mind does. It tries to picture a tiny dot sitting in a black void. It wants a center. It wants an edge. It wants a nice, clear diagram with arrows and labels, and maybe one very confident teacher pointing at it with a stick. But the beginning of the universe does not behave like everyday things. There may not have been a center in the usual sense. There may not have been an edge. Those are comfortable ideas from ordinary life, and the early universe is not interested in being ordinary. Science can trace the story back incredibly far. It can describe the universe when it was unimaginably young, unbelievably hot, and packed more tightly than anything you have ever known. But there is a limit. If you go all the way to the very first instant, our current physics stops being complete. The equations that work beautifully for stars and galaxies and planets begin to lose their grip. This is not failure. This is honesty. And there's something deeply soothing about that. Science does not pretend to know more than the evidence allows. It tells you where the picture is clear, where it starts to blur, and where the fog still waits. That honesty makes the known parts feel even more solid. Humans figured this out by looking, measuring, testing, comparing, and thinking with almost unreasonable patience. We watched galaxies move. We studied light. We learned how matter behaves under extreme conditions. We followed clues left across the sky. So when science says very calmly, this is where we can see, and this is where our current view fades, it feels trustworthy. It feels like someone handing you a lantern instead of a fantasy. One of the most comforting ideas here is that asking what happened before the Big Bang may not be a simple question. It sounds simple because your mind lives in time. Your mind likes order. First one thing, then another. Breakfast, then work, then maybe pretending one email does not exist until tomorrow. But if time itself began with the universe, then asking what came before it may be like asking what is north of the North Pole. The question sounds normal, right up until the map quietly stops working. That is such a strange thought, and such a gentle one. Time may not be a giant river that was already flowing while the universe jumped into it. Time may be woven into the universe itself. So when the universe begins, time begins too. Not because someone set a clock on a shelf and pressed start, but because the clock, the shelf, the room, and the meaning of start all belong to the same event. You do not really need to force that into a neat mental picture. The beginning of the universe is allowed to stay mysterious. In fact, it becomes more beautiful when you stop trying to shrink it into something familiar. It is enough to feel the wonder of it. There was a first state of reality, and from that state came everything that would ever happen. People often say the universe came from nothing, but that sentence can mean too many different things. In ordinary life, nothing means an empty box, an empty room, an empty wallet after you convince yourself one coffee would not hurt. In physics, nothing is trickier. Even empty space is not simple. It has structure, laws, and strange energy behavior. So the safest way to think about the birth of the universe is not as a magic trick from absolute nothing, but as the earliest state we can meaningfully talk about, a state so extreme that everyday language starts wobbling. What we do know is astonishing enough. The early universe was unimaginably hot. Not hot like a desert, not hot like lava, not hot like summer when the power goes out and everyone suddenly remembers every bad decision they made. This was a temperature so extreme that the forms of matter could not yet exist in the way they do now. It was also unimaginably dense. Again, your brain wants a comparison. A pea, a grain of sand, a marble, something small enough to put beside a ruler. But the beginning resists that. It was not a tiny object sitting somewhere. It was the whole universe in an early state, a condition where everything was compressed beyond normal understanding. That is one of the loveliest parts of this story. The universe was once smaller, hotter, and simpler, but it was already carrying the full possibility of everything that would come later. Every star, every ocean, every mountain, every tree, every bird wing, every face, every poem, every soft lamp in a quiet house, every thought you have ever had. Not in their finished form, of course. Nothing recognizable yet. No galaxies, no planets, no drifting clouds. But the possibility was there, folded into the opening condition of reality. And it was not pure chaos. That matters. The early universe was extreme, but was not nonsense. It followed rules. The laws of physics were already shaping what could happen. The same deep patterns that would one day allow atoms to form, stars to shine, and life to emerge were already present in the earliest moments we can describe. There is comfort in that. The universe did not begin as a random mess that somehow got lucky. It began with order in its bones. You can almost feel the steadiness of that. Long before galaxies existed, long before there was a planet called Earth, long before any living thing took a breath, reality already had structure. Gravity was not making it up as it went. Physics was not improvising like a student trying to present a book report on a novel they absolutely did not read. The universe had laws from the beginning. It had a grammar, a rhythm, a quiet kind of discipline. That is why the birth of the universe can feel less like violence and more like release. It is the opening of possibility, the first condition from which all future complexity will grow. A beginning so intense that it is hard to imagine, yet so orderly that everything after it can unfold. You're listening tonight because that unfolding never stopped. The universe did not start and then become unrelated to you. It started, and much later it became stars, and much later those stars made heavier elements, and much later one small world grew oceans and weather and living things, and much later a person ended up here hearing this story in the dark. So you are not separate from the beginning. You belong to it. You are one very late expression of an ancient event. The atoms in your body were not present in their current form at the start, but the rules that made those atoms possible were already there. The foundations of your existence reach all the way back to the birth of the cosmos. In that sense, the beginning of the universe is not just a distant scientific topic. It is the deepest part of your family history. And somehow that makes ordinary life feel softer. Deadlines, worries, little embarrassments, all the things that stomp around in your head wearing oversized boots, they shrink a little when placed beside this enormous story. Not because your life does not matter. It does. But because your life is held inside something far older and wider than today's stress. The universe has been unfolding for billions of years. You do not need to carry all of it tonight. The beginning also has a quiet intimacy to it. Every comforting thing you know came from a universe that began this way. Warm light through a window, rain against glass, music in another room, someone laughing in a kitchen. All of it exists because reality started in a form so hot and dense and mysterious that language still struggles to hold it. That is almost absurdly generous. The universe began in conditions beyond imagination, and somehow, after ages of change, it became a place where softness could exist. So you stay for a moment at that threshold. No stars yet, no galaxies yet, no planets turning under dawn. Only the earliest universe, fierce and compact and full of hidden futures, holding everything that will someday become familiar. It is the quietest kind of beginning, not because nothing is happening, but because everything is waiting there at once, ready to become the long, beautiful story that follows. That hidden future does not stay folded for long. The early universe begins to change with astonishing speed, though speed is almost too ordinary a word for what happens next. You are dealing with a reality so young that even the smallest fraction of a second feels enormous by comparison. In that first tiny sliver of cosmic history, the universe is not calmly sitting in one state, waiting to be described. It is transforming. Space itself is stretching. Conditions are shifting almost faster than language can follow. This is one of the most relaxing facts about the birth of the universe, even if it sounds wildly dramatic at first. The universe did not need to be pushed outward through some giant emptiness. It expanded because expansion was part of what it was doing. Space was not a container. Space was the thing changing. That may be the single most important image to keep close here. Not debris flying across a room. Not sparks spraying from a firework. More like the room itself quietly becoming larger, with every point carried along, because the room is the thing growing. You can picture a loaf of bread rising in the oven. One of those examples scientists love because bread is humble and reliable and never complains about being used in cosmology. Imagine raisins inside the dough. As the dough expands, each raisin sees the others moving away. No single raisin is the center of the expansion. The dough between them is increasing. The universe works something like that, except with far fewer baked goods and far more existential consequences. Galaxies are not raisins yet, of course. Nothing that neat exists this early. But the principle helps. Things separate because space expands. And in the earliest moments, that expansion may have been unbelievably fast. There's an idea in cosmology called inflation, and despite the name, it has nothing to do with grocery prices, although both can make a person stare into the distance and question reality. Cosmic inflation is the idea that the very young universe went through a brief episode of extremely rapid expansion. Not ordinary expansion, not a steady widening, a sudden, immense stretching of space itself. This matters because it helps explain several strange features of a universe we see today. On the largest scales, the universe looks remarkably smooth. Regions very far apart have almost the same overall temperature and structure, which is odd if they never had time to influence each other in the usual way. Inflation offers a graceful answer. Before that explosive stretching, those regions may have been much closer together, close enough to share the same basic conditions. Then space expanded so quickly that they were flung far apart, like a tiny pattern pulled across an enormous sheet. There is something almost tender about that image. The young universe may have begun in a very small, connected state, and inflation preserved that early sameness by stretching it outward. The vast cosmos inherits a memory of closeness. Even the most distant reaches of space may still carry the imprint of having once belonged to a much more intimate beginning. You do not need to imagine this as chaotic. Strange, yes. Extreme, absolutely. But it is still physics. It is still a lawful process. The universe is not panicking. It is not improvising. It is unfolding according to rules that are difficult, beautiful, and a little smug in the way the deepest truths often are. The laws of nature are already at work, shaping how energy behaves, how space changes, how the early cosmos moves from one state to another. One of the hardest ideas here is that the universe does not expand into anything. Your everyday instincts keep trying to sneak that back in. If something grows, it must grow into a surrounding space. If a balloon inflates, it expands into the room around it. But with the universe, the room is not separate from the process. Space is not on standby outside the cosmos, waiting to receive it. The expansion is not happening into an external background. The background itself is what is expanding. That can feel slippery at first, like trying to hold water in your hands. But once it settles, it becomes oddly peaceful. It means the universe is complete in its own story. It does not need an outside stage to justify its growth. It carries its own geometry with it. It is enough unto itself, which is a very grand thing for reality to be. As space expands, the universe cools. That connection is deeply important. Expansion and cooling belong together. When something spreads out, its energy becomes less concentrated. The early universe starts impossibly hot, but as it grows, the temperature drops. You can think of it as intensity making room for complexity. A universe that is too hot cannot keep stable structures for long. Everything is too energetic, too restless. Cooling is what allows new behavior to emerge. But this is still an era of incredible simplicity. No atoms yet. No stars. No planets. Not even nuclei in the familiar sense during the very earliest part of this stretch. The universe is filled with energy and fundamental particles in a state so dense and hot that ordinary matter, as you know it, cannot settle into place. Particles appear and interact in a furious but rule-bound sea. Matter and radiation are deeply entangled in the story. The cosmos is alive with transformation. If you could somehow witness this, which you absolutely cannot because you're made of matter that would object very strongly, you would not see tiny marbles floating in blackness. There is no normal visual scene here. No little sparks hanging in a void. The universe is more like a whole environment of intensity, everywhere at once, dense with energy, with the ingredients of later structure still in their rawest form. And still, underneath all that extremity, there is a developing calm. Not the calm of silence, but the calm of order. Expansion gives the universe room. Cooling gives it possibility. The earliest wildness is not pointless. It is the necessary opening movement in a long composition. Everything that will later become stable first passes through this state of overwhelming heat and compression. The cosmos is not failing to be gentle. This is how gentleness becomes possible. There's also a quiet miracle in how tiny fluctuations survive this process. The early universe appears smooth on large scales, but not perfectly smooth. There are minuscule differences, tiny variations in density from one place to another. Very, very small. Almost nothing. The kind of irregularity you might overlook if you were expecting drama. But those tiny differences matter. They will eventually become the seeds of larger structure. Regions that are just a bit denser than average will later attract more matter through gravity. They will help shape the future architecture of the cosmos. That is one of the loveliest patterns in all of science. The grandest structures in existence begin from slight unevenness. Not from some gigantic flaw, not from cosmic mess, but from delicate little ripples. The universe does not need huge imperfections to become interesting. It only needs the faintest departures from total sameness. From those tiny irregularities, everything later can grow. And there is something very human in that, even though this happens long before humans exist. Perfection is static. Absolute sameness would be sterile. A universe with no variation at all might remain elegant and simple, but it would not become rich. It would not develop stars, galaxies, planets, oceans, or minds that lie awake wondering how all this began. A little unevenness turns out to be fertile. The cosmos needs just enough texture to create a future. So the early expansion is not merely a blowing outward. It is the setting of conditions. It is the universe choosing, through physics rather than intention, the kind of story it will be able to tell. A universe that expands too differently would look different later. A universe with no tiny variations would remain eerily plain. A universe that cooled under different rules might never form the structures that eventually make life possible. This early era is not a rough draft. It is the foundation. And the timescales here are almost insulting to the ordinary mind. Fractions of a second carry transformations so vast that human history feels like a blink at the far end of the sentence. The first second of cosmic history contains events of immense importance. Forces behave differently. Particles interact in ways tied to extreme energy. The universe cools through thresholds that change what can exist. It is a reminder that time is not measured only by duration. Some moments are dense with consequence. You know this already from life in a smaller way. A single second can hold a breath before news arrives, a glance across a room, the click of a lock, the first cry of a newborn, the instant you realize the train door has closed and you're very much not on the correct side of it. Duration alone is not the whole story. Meaning packs itself unevenly into time. The early universe is that truth written on the largest possible scale. Tiny intervals carry immense change. As the cosmos keeps expanding and cooling, some of the most extreme conditions ease. The universe becomes less compressed, less violently energetic. Not quiet yet, not simple in the familiar way, but more open. It is beginning the long transition from pure early intensity toward a reality where stable things can eventually exist. You are still far from atoms, far from light moving freely through space, far from stars waking up for the first time. Those belong to later pages. For now, the universe is only learning how to stretch, how to cool, how to make room. And room is such an important word here. Expansion creates room not just in the geometric sense, but in the story sense. Room for particles to behave differently. Room for temperature to fall. Room for tiny variations to matter. Room for complexity to arrive one careful step at a time. The cosmos does not rush toward familiarity. It earns it slowly through lawful change. That is why the earliest unfolding feels so profound. The universe begins in a state beyond ordinary imagination, then almost immediately starts making itself inhabitable in principle, though not in comfort. The violent simplicity of the beginning gives way to a slightly less violent simplicity, and that is progress. That is the cosmos preparing, without any plan and without any audience, for everything that will one day follow. You can rest with that image for a moment. Space widening without edges. Heat loosening its grip. Tiny ripples surviving inside a mostly smooth hole. The young universe becoming larger, cooler, and more structured, not through chaos but through astonishing consistency, is still almost unimaginably early. The darkness has not lifted into stars. The great patterns of the cosmos have not yet become visible. But the first gentle unfolding is underway, and reality has begun its long habit of becoming more spacious than it was a moment before. The universe keeps opening and cooling, and after that first astonishing stretch, It enters a long, dense youth where almost everything is still too hot and too crowded for light to move in any simple way. This is one of the strangest parts of the story, because you might assume that once light exists, it simply rushes off across space and gets on with being light. Very confident behavior, very on brand. But the early universe is not ready to allow that yet. Light is there, absolutely. It has been there from very early on. The problem is that space is filled with charged particles, and those particles keep scattering light in every direction. So even though the cosmos is glowing, it is not transparent. It is more like a bright fog than a clear sky. If you were somehow present, which remains a terrible idea for several reasons, you would not see a view stretching into the distance. You would not see stars or shapes or horizons. Light would be trapped in a constant jostling, bouncing from particle to particle, never getting very far without being interrupted. The universe is luminous, but it is not yet see-through. That is a beautiful distinction. Something can be full of light and still hide itself. The young cosmos is shining everywhere, yet keeping its secrets. It is wrapped in a veil made not of darkness, but of too much interaction. The light is not absent. It is busy. During this period, the universe is mostly a hot plasma, a word that sounds slightly futuristic and a little smug, as if matter has upgraded to premium features. Plasma is a state where electrons are not bound neatly to atomic nuclei. Everything is too energetic. Electrons move freely, nuclei move freely, and photons, the particles of light, keep colliding with these charged particles. In a dense plasma, light cannot simply stream away. It gets scattered again and again, redirected constantly, like trying to walk across a crowded room where every single person insists on gently but firmly blocking your path. This goes on for a very long time by human standards, though not by cosmic ones. The universe continues expanding, and because it expands, it continues cooling. That relationship remains one of the deepest rhythms in the whole story. More room means less concentrated energy. Less concentrated energy means lower temperature. Lower temperature means new kinds of stability can begin to appear. Eventually, the cosmos reaches one of the most important thresholds in its history. It cools enough for electrons to slow down and settle into orbit around atomic nuclei. This is the moment when neutral atoms can finally form in large numbers, mostly hydrogen and helium. It sounds modest. Electrons pair up with nuclei. Very neat. Very tidy, but this changes almost everything about the visibility of the universe. Once electrons are bound into neutral atoms, there are far fewer free charged particles to scatter photons. And that means light can finally travel much more freely. The universe, which had been like an endless glowing fog, becomes transparent. This is one of the most elegant turning points in all of cosmology. It is not the creation of light, but the release of light. The cosmos does not suddenly switch on. It clears its throat. This happened when the universe was about 380,000 years old. That number is wonderful because it sounds ancient from a human point of view and absurdly young from a cosmic one. The universe is still an infant, really, but already it has changed from an opaque blaze into a place where photons can finally move across great distances without constantly crashing into everything around them. The curtain opens, the glow escapes, and some of that light is still here. That is one of the most relaxing and astonishing facts about the birth of the universe. The early universe left behind an afterglow, a faint sea of radiation that still fills all of space. It comes to us from every direction. It is not a beam from one star or one galaxy or one special place. It is the cooled remnant of that ancient light, stretched by cosmic expansion over billions of years until it now exists mostly as microwave radiation. This is called the cosmic microwave background. The name is a little underwhelming. Honestly, cosmic microwave background sounds like something you discover behind the office fridge while looking for your lunch. But what it actually means is breathtaking. It is the oldest light we can observe directly, a snapshot of the universe when it first became transparent. When scientists study it, they are looking at a baby picture of the cosmos. A very grainy baby picture, yes, but still one of the most important images in human thought. This afterglow is not hot anymore in any ordinary sense. Today, it is incredibly cold, just a few degrees above absolute zero. That is because the universe has expanded enormously since that early release of light. As space stretches, the wavelengths of that light stretch too. Its energy drops. What was once a brilliant hot glow has cooled into a faint microwave whisper spread across the sky. And yet it is everywhere. You could point a microwave detector at almost any part of the sky and find it. Not because the universe is repetitive, but because this background really does surround us on all sides. It is like living inside the echo of the beginning. Every direction holds a memory of that early release, as if the cosmos has never completely stopped humming its first clear note. There is something deeply comforting about that. The universe has changed almost beyond recognition since those first hundreds of thousands of years. Galaxies formed, stars ignited, heavy elements were forged, planets came together, oceans appeared, life emerged, entire civilizations rose and vanished. And still, beneath all the later complexity, the early afterglow remains, quiet and patient, bathing everything in the oldest light we can see. This glow also tells us something profound about the character of the universe. It is astonishingly uniform. No matter where we look, the cosmic microwave background has almost the same temperature. Not perfectly identical, but extraordinarily close. That smoothness is one reason inflation became such an important idea, because it helps explain how distant regions could share such similar conditions. The early universe, despite all its intensity, was remarkably even on large scales, but not perfectly even. And once again, that tiny imperfection becomes the seed of everything interesting. When scientists map the cosmic microwave background in detail, they find minute temperature differences from place to place. Tiny fluctuations, extremely small variations, just a little warmer here, a little cooler there. These are not random smudges with no meaning. They are the imprint of those early density ripples you were carrying with you from the previous stretch of the story. Regions that were slightly denser and slightly hotter, regions that were slightly less dense and slightly cooler. These delicate differences are the fingerprints of future structure. That is such a lovely idea that it almost feels written for drama, except the universe did it first and did it better. In the oldest visible light, you can already see the faint blueprint of what will later become galaxies and clusters of galaxies. The great architecture of the cosmos begins as whisper-small variations in the baby glow. This is why the cosmic microwave background is not just a pretty fact. It is evidence. Powerful, beautiful evidence. It tells us the universe really was hotter and denser in the past. It tells us it expanded and cooled. It tells us when atoms formed and light began to travel freely. It tells us the early cosmos was smooth, but not perfectly smooth. It tells us that the story is real. And human beings found this out in a way that feels almost mischievously poetic. In the 20th century, two radio astronomers, Arno Penzias and Robert Wilson, were working with a sensitive antenna and found a persistent background noise they could not get rid of. They checked everything: equipment, interference, bird droppings, because reality does enjoy a little comedy in the middle of great discovery. The signal remained. It was coming from the sky itself. They had stumbled onto the ancient afterglow of the early universe. Imagine that for a second. The echo of the cosmos becoming transparent had been passing through space for billions of years, and eventually a species on one small planet built instruments delicate enough to notice it. Not bad for primates, who also lose arguments to automatic doors. That discovery changed cosmology. Suddenly, the birth of the universe was not only a theoretical idea supported by expansion. It had a fossil light, a preserved glow. a relic from the time when the universe first became clear enough for photons to move freely. It was as if the cosmos had signed its own baby portrait and left it out where patient minds could find it. The release of light also marks a subtle emotional turning point in the story. Up until now, the universe has been intensely physical but visually hidden, full of energy, full of transformation, yet not open to sight in any ordinary sense. With transparency, that changes. The cosmos becomes readable in a new way. Light can begin crossing vast distances, carrying information with it. From this point on, the universe starts becoming visible to itself in a manner of speaking. It acquires the possibility of long-range light. No stars yet, of course. No galaxies glowing in darkness. That grandeur still lies ahead. For the moment, what exists is a newly transparent sea of mostly hydrogen and helium, expanding into greater quiet, filled with ancient radiation moving freely at last. The universe has not become familiar, but it has become clear. And clear is such a lovely word here. Clear does not mean complete. It does not mean fully formed. It does not mean cozy, settled, and ready for curtains and tea. It means that the fog has lifted. The first veil has thinned. Light, which was always present, can finally go the distance. You can almost feel the relief of it. For hundreds of thousands of years, photons have been trapped in a constant dance with charged particles, bumping and scattering, unable to travel far in a straight line. Then the temperature falls, atoms form, and suddenly the universe opens. The light streams out. The afterglow begins its vast journey. Space becomes transparent enough to remember. That memory still reaches you tonight. It passes through the same universe that once held it captive. It has been stretched and cooled almost beyond recognition, but not erased. It remains as a gentle background presence, a dim ancient bath of radiation whispering that the universe was once young, dense, bright, and beautifully hidden. When you hear that phrase, the oldest light in the universe, is not a poetic exaggeration. It is a literal trace of the moment when the cosmos first allowed light to roam freely. And what a patient kind of freedom it is. No rush, no fanfare, just photons setting out across expanding space, carrying with them a portrait of the young universe, while the vast dark age ahead waits quietly for the next act. The fog has cleared, the afterglow has escaped, and the cosmos, still simple, still starless, is preparing for a much longer silence before the first true lights begin to wake. After that ancient light slips free, the universe enters one of its quietest and most haunting ages. The great glowing fog is gone. Space is transparent. Photons are on their way across the widening cosmos. And yet, strangely, the universe does not become bright. It becomes dark, not empty dark, not dead dark, just a deep, patient darkness. This is one of the most relaxing facts about the birth of the universe. There was a very long time when the cosmos had no stars at all, no galaxies shining across black space, no warm suns, no glowing nebulae, no planets reflecting anything. The universe had already begun, expanded, cooled, and cleared enough for light to travel, but there were still no new visible sources of light to fill the darkness. The old afterglow remained, of course, stretched and fading as space expanded, but the dramatic lights people usually imagine when they think of the universe had not arrived yet. The cosmos had become transparent before it had become luminous in the way we usually mean it. That gap matters. It tells you the universe was willing to wait. For millions of years, what filled space was mostly hydrogen, with a good amount of helium, and only the tiniest traces of a few other things. No carbon yet in useful abundance, no oxygen for oceans, no iron for blood, no calcium for bones, no silicon for stones and glass, and all the devices people eventually stare at in the dark instead of sleeping. The universe was chemically simple in an almost severe way. It had the basic ingredients from its earliest cooking, and that was it. Hydrogen dominated everything. Just the lightest, simplest element, one proton with one electron. Almost comically modest. If the later universe is an orchestra, this stage is mostly a single note being held for an incredibly long time. And yet that simplicity is part of what makes it so beautiful. The universe is not rushing to show off. It is not trying to impress you with color and noise and instant complexity. It is taking its time. It is holding a small set of ingredients and letting gravity work patiently in the background. That patience is one of the deepest patterns in cosmic history. After the violence of the earliest conditions and the strange brilliance of the released afterglow, the universe settles into an era where almost nothing looks dramatic from the outside. This is sometimes called the cosmic dark ages, which sounds much more menacing than it really is. It makes it sound as if the universe forgot to pay the electric bill and wandered into a gloomy fantasy novel. But the darkness is not sinister. It is fertile. It is the dark of preparation. There is still structure growing here, even if you cannot see it with ordinary light. Those tiny density ripples carried forward from the earliest universe have not disappeared. They are still present, still doing their quiet work. Places that are just a little denser than average begin to pull in more matter through gravity. Very slowly at first, almost insultingly slowly, if you prefer your history with a little more action. But slowly is enough. Given enough time, gravity can turn a faint preference into a destiny. And gravity is tireless. It does not need applause. It does not need a deadline. It does not panic. It simply keeps pulling. So across this dark young universe, matter begins to gather into larger clumps. Invisible frameworks form, shaped in large part by dark matter. That mysterious substance which does not shine, does not absorb light in the normal way, and yet still exerts gravity. You cannot see dark matter directly, but the universe clearly feels it. It helps create the scaffolding on which later cosmic structure will grow. Ordinary matter, the stuff that will one day become stars and planets and tea kettles and tired shoulders, starts falling into these gravitational wells. There is something strangely comforting about the fact that so much of the universe's future depends on things you cannot see directly. The darkness is not absence. It is hidden organization. It is a stage where invisible structure comes first and visible beauty follows later. If you could drift through this era, which would still be a very poor survival plan, you would not see much in the human sense of seeing. There are no stars yet to light your way, no nearby suns, no galaxies glittering in spirals. The universe is vast, mostly neutral hydrogen and helium, growing colder and more spread out as it expands. But beneath that simplicity, the architecture of the future is forming. That is what makes this darkness feel so grand. It is not blank. It is loaded. The hydrogen filling space is calm compared with earlier eras, but it is not doing nothing. Gas is falling toward denser regions. Dark matter halos are growing. Tiny irregularities become slightly less tiny. The smoothness of the early universe begins to develop texture. Not quickly. The cosmos is still deeply committed to taking its time. But the process is underway. And time, here, becomes almost impossible to feel in normal terms. We're talking about millions of years, tens of millions, eventually more than 100 million years before the first stars begin to appear. Human history, by comparison, is a breath on a window. Even the entire age of our species is a very small flicker beside this prolonged early waiting. The universe spends far longer preparing for stars than any impatient mind would choose. It does not seem to mind. That may be the most soothing lesson in this whole stretch. The universe does not treat waiting as wasted time. In human life, waiting often feels annoying. You wait for messages, for test results, for train, for healing, for clarity, for some version of yourself to catch up with the life you're trying to live. Waiting can feel empty because you do not get to see what is changing underneath it. But cosmic waiting is different. Or maybe it is simply honest about what all waiting really is. Under the surface, things are moving. Structures are forming. Conditions are becoming possible. The dark age of the universe is not a pause in the story. It is the story slowly becoming ready for light. The old afterglow is still present during this time, but it keeps stretching to longer wavelengths as space expands. It fades farther from anything like visible light. The universe is cooling, widening, and darkening in the ordinary visual sense, even while it is building complexity in the gravitational sense. This is a wonderful contrast. To the eye, less and less. To the future, more and more. The chemistry remains simple, but not entirely frozen. In some places, under the right conditions, a little molecular hydrogen can begin to form. That matters because molecules can help gas cool more effectively, and cooling helps gas collapse more easily under gravity. The details are delicate, but the effect is huge. If gravity is the hand gathering matter inward, cooling is what lets the gas surrender instead of resisting through heat. A cloud that cools can shrink further. A cloud that shrinks further can become denser. A denser cloud is one step closer to eventually igniting a star. So even in the dark, the first ingredients of future light are being prepared. This is why the age feels less like emptiness and more like inhalation. The universe is drawing itself together, slowly, silently, on scales too vast for ordinary intuition, but unmistakably. Regions of gas deepen. Dark matter halos merge and grow. Gravity keeps selecting places where the future will arrive first. Nothing flashy. No cosmic drumroll. Just steady accumulation. And because there are no stars yet, the darkness is complete in a way the modern universe almost never allows. Today, the cosmos is full of light sources. Stars, galaxies, quasars, glowing gas clouds, whole structures blazing across space. Even between galaxies, there is history shining somewhere. But during this early era, before the first stars, there is no starlight at all. Imagine the honesty of that. A universe already immense, already structured in seed form, and still without a single star. It is almost hard to believe such a thing can exist. We are so used to connecting the universe with glittering skies that a starless cosmos feels like a contradiction. But it is real. There was a time when a universe had shape without sparkle, matter without fire, possibility without display. And this starless age is one reason later light matters so much. The first stars do not merely add brightness. They break a silence that lasted an extraordinarily long time. They arrive in a universe that has earned them through patience. There is also a strange elegance in how little the early universe needs in order to begin building everything. It starts with basic matter, gravity, tiny unevenness, time, and the willingness to remain mostly dark for ages. That is enough. No elaborate ingredient list. No cosmic vekerater chusingaksense. Just simple laws, simple elements, and unimaginable duration. From that, all later richness will come. The long darkness also reminds you that the universe is under no obligation to be immediately beautiful in the ways people expect. It does not begin with fireworks and remain dazzling forever. Sometimes beauty in cosmic history is hidden for a while. Sometimes magnificence is still gathering strength where nobody could yet witness it. Sometimes the most important stage in a process is one that looks from the outside like almost nothing. That idea feels surprisingly human too. Some of the deepest changes happen in periods that do not look impressive at all. You do not always glow while becoming. The universe certainly did not. And still, this age is magnificent. Not visually perhaps, but conceptually. Imagine space filled with neutral hydrogen, spread across enormous distances, shaped by tiny, ancient ripples, gradually pooling under gravity into denser regions, while invisible dark matter builds the great hidden web beneath it. Imagine a cosmos young enough to have no stars and old enough to be preparing them. Imagine millions of years passing in almost perfect darkness while the foundations of future galaxies gather themselves quietly together. That is not boring. That is majestic. It also gives scale to what light really means. Light is precious because darkness came first, and because darkness stayed a while. The first stars will matter not only because they shine, but because they rise out of a universe that spent so long waiting for them. They will not appear in a random void. They will appear in a cosmos that has been leaning toward them for ages. So this long, beautiful darkness stretches on. Hydrogen drifts and gathers. Gravity persists with its endless patience. The invisible framework of dark matter shapes where matter collects. The old afterglow keeps fading into longer wavelengths. The universe grows larger, colder, and more textured, although still mostly hidden from sight. No stars yet, no galaxies shining, just the deep calm before the first fires wake. And because the cosmos has waited this long already, it can wait a little more, drawing gas inward, deepening structure, letting the first true beacons of the universe prepare themselves just beyond the edge of visibility. And then, after all that waiting, the universe finally does something almost impossibly dramatic in the gentlest possible way. In scattered pockets of that vast darkness, gravity gathers enough hydrogen and helium into dense, collapsing clouds that the pressure at their centers becomes extreme. The gas falls inward, heats up, tightens further, and keeps going until nature reaches one of its great thresholds. Deep inside these first collapsing objects, atomic nuclei begin to fuse. The first stars wake. It is hard to overstate how important that is. For a very long time, the universe had no stars at all. It had matter, gravity, space, time, the fading afterglow of its own early transparency, and all the raw possibility in the world, but no true starlight. Then, in certain dense regions, the waiting ends. The first stars ignite, and the dark age begins to break. Not everywhere at once. That is part of what makes it beautiful. The cosmos does not suddenly blaze like someone flipping on a stadium light. Illumination begins locally, carefully, in rare places where conditions have become right. Here and there, across the early universe, a first generation of stars appears inside the densest clouds. Tiny islands of fire begin to puncture the dark. If you could witness this from some safe and impossible distance, you would not see a smooth dawn spread evenly across the cosmos. You would see darkness holding on across enormous regions, while isolated lights emerge inside it. A long night learning how to make morning. These first stars were probably very different from the stars you know today. The modern universe contains many generations of stellar history. Stars are born from gas that has already been enriched by earlier stars. That means today's stars often form in material containing heavier elements like carbon, oxygen, silicon, and iron. But the first stars had none of that. They formed out of almost pure hydrogen and helium, the simple elements the universe had from its beginning. That simplicity changes everything. Heavier elements help gas clouds cool more effectively, and cooling helps clouds fragment into smaller pieces. Without those heavier elements, the first star-forming clouds behave differently. Many scientists think the earliest stars were often much more massive than typical stars today. Enormous, brilliant, short-lived giants. Stars that burned hot and hard, with a kind of reckless efficiency the universe would later become less dependent on. There is something very moving about that. The first stars may have been giants because the young universe still had so little chemical subtlety. It had not yet learned variety. It had not yet built the ingredients needed for gentler, smaller, longer-lived stars in abundance. So the first lights were not little careful candles. They were more like great furnaces, briefly magnificent, born from simplicity and intensity. And yet even that has a calming logic. The universe does not get to the delicate later forms without these bold earlier ones. Before there can be worlds, there must be makers. Before there can be chemistry rich enough for life, There must be stars willing to live fast and die generously. Inside a star, fusion is what keeps gravity from winning completely. Gravity pulls inward all the time, relentless as ever. But when a star ignites, fusion in the core releases energy. That energy creates outward pressure. A balance appears, one of the most elegant balances in nature. Gravity compresses, fusion resists. The star shines because it is forever negotiating between collapse and release. The first stars enter that negotiation in a universe still mostly dark and young. Their light must have felt almost shocking, though of course there was nobody there to be shocked. No eyes, no language, no audience. Just physics suddenly glowing in places where only darkness had ruled before. These first stars do more than shine. Their light begins changing the universe around them. The radiation pouring from them is intense, especially because many of them were likely so massive and hot. Ultraviolet light from these stars starts interacting with the neutral hydrogen that filled most of space. It strips electrons away again, turning neutral atoms back into ionized gas in the regions around stars. Little bubbles of altered space appear around these first lights. This begins a slow transformation called reionization. It is a long process, not a single event. As more stars form, and later the first galaxies and quasars add their own fierce light, more and more of the hydrogen between cosmic structures becomes ionized. The universe, which had become neutral after the release of the ancient afterglow, starts changing state again under the influence of its first luminous objects. And that means the first stars do not merely arrive inside the universe. They begin reshaping it. Their radiance travels outward, touching gas that had floated quietly in darkness for ages. Their heat affects the surrounding material. Their winds and radiation alter future star formation nearby. The first stars become sources of both light and consequence. They are not passive decorations in the sky. They are active forces in the next stage of cosmic history. Still, one of the loveliest things about stars is that their deepest work happens inside. In their cores, simple elements are transformed into more complex ones. Hydrogen fuses into helium. In more massive stars, later stages of fusion can build heavier nuclei. This is the beginning of cosmic alchemy, though it is better than alchemy because it actually works. The universe began with mostly hydrogen and helium. That was enough for the first stars to form, but not enough for the later richness of chemistry. The heavier elements had to be made somewhere, and stars are where that making begins. They're not just lamps. They're furnaces of creation. This is one of the most comforting truths in all of science. Stars shine by changing the universe into a place where more interesting things can exist. They take simplicity and turn it into possibility. They turn early plainness into future abundance. Carbon, oxygen, nitrogen, neon, silicon, iron, all the elements that later matter so much, owe their existence to stars and what stars do under pressure. The first stars are where this grand enrichment begins. Not all at once, and not in its final form, but truly begins. The cosmos, after ages of darkness and chemical simplicity, starts making new ingredients. And because many of these earliest stars were probably so massive, they did not last very long. That sounds sad in a human register, but in cosmic terms, it is part of their gift. Massive stars burn through their fuel quickly. They live brightly and briefly. When their cores can no longer support the inward force of gravity, they reach violent endings. Some of the first stars likely died in powerful explosions, scattering newly forged elements into the surrounding space. That scattering matters almost as much as the forging itself. It is not enough for a star to make heavier elements if those elements remain locked away forever. The universe needs distribution. It needs the products of stellar fusion to escape into space, where they can mix into later clouds of gas and dust. Future stars, future planets, future chemistry all depend on this sharing. So the first stars live, shine, transform, and in many cases die in ways that enrich the cosmos. Their deaths seed the next generation. The universe becomes chemically less simple because stars refuse to keep their work to themselves. There is something wonderfully generous about that pattern. The first stars are not the final goal. They are the beginning of a lineage. They light the dark, alter the gas around them, and manufacture the ingredients for later worlds they will never see. Their existence is brief, but their influence extends forward through everything that comes after. When you think of starlight, it is easy to think only of beauty. A bright sky, a quiet night, something romantic enough to make people write poetry they are very pleased with. But starlight is also labor. A star is a place where matter is under such pressure that the universe begins making new possibilities. That is true of stars now, and it was true in the first great wakeful lights as well. Those earliest stars also begin to knit the dark universe into a new kind of landscape. Their light creates contrast where before there had mostly been uniform shadow. Their radiation carves out ionized regions. Their deaths stir surrounding gas. Their existence marks the transition from a universe shaped mainly by gravity and expansion into a universe increasingly shaped by luminous astrophysical objects. The story is becoming brighter, but also more complicated. And still, the darkness does not vanish at once. The first stars are rare at first. Vast reaches of space remain dark. This is not a clean replacement of night with day. It is a slow contest between darkness and the first wave of light. One region brightens while another stays untouched. One star dies while another forms. The cosmos becomes patchy with illumination. That patchiness makes the story feel more real. Change rarely arrives evenly. It comes in pockets, starts, interruptions, bursts of intensity, surrounded by long stretches of quiet. The early universe learns brightness the same way many things do, unevenly. The first stars also belong to a much larger hidden structure. They form inside concentrations of matter that are themselves part of growing cosmic architecture. Dark matter halos continue to gather and merge. Gas falls inward. More stars begin to form in groups. These are the earliest steps toward the first galaxies, though the stars come first as the real pioneers. They are the opening lights before the larger cities of the cosmos are built. It is worth resting for a moment on how improbable this all feels from a human scale. The universe begins in unimaginable heat and density. It expands, cools, clears, waits in darkness, and then, after hundreds of millions of years, gravity gathers plain hydrogen and helium into luminous engines that begin making entirely new elements. There is such grandeur in that sequence, and yet it all follows from patient laws acting over time. No shortcuts, no grande intervention, just reality doing what reality does, with extraordinary consequences. And those consequences eventually include you. Not yet, of course. The first stars are still far too early for anything like Earth or breathing or warm coffee or tired shoulders at the end of a long day. But the line has begun. The universe has crossed a threshold from which later complexity becomes much more achievable. Once stars exist, chemistry can deepen. Once chemistry deepens, future clouds can form different kinds of stars. Once enough generations of stars have lived and died, planets become possible in a richer sense. Solid worlds, rocky surfaces, complex molecules, oceans, atmospheres, bodies. All of that depends on stellar ancestors. So when the first stars wake, they do not simply decorate the early universe. They begin the chain that leads from raw simplicity to inhabited worlds. Their light is the first visible sign that the cosmos is becoming capable of more than emptiness and gas. Their furnaces begin the work that will one day make soil, metal, water, and thought, which makes the first sunrise of the universe feel even more extraordinary. It is not only beautiful, it is productive. It is the first visible proof that the cosmos can become richer than it started. You can almost sense the mood of the universe changing here. The long, beautiful darkness is still present, but no longer complete. In scattered regions, there are now fires. Enormous young stars blaze in halos of gathered matter, sending out fierce radiation, altering the gas around them, and beginning the ancient craft of element making. The cosmos has found its first true lanterns, and once light like that exists, the story can never return to what it was before. The Dark Age is broken. The first stars have spoken in heat and radiance. Their brief lives begin the slow enrichment of everything. Out of hydrogen and helium alone, the universe has made fire, and through fire it has started learning how to make the materials of future worlds. And once the first stars have broken the dark, the universe begins assembling something even grander than single points of light. Those early stars do not remain lonely forever. They form inside growing pockets of matter, and those pockets keep pulling in more gas, more stars, more structure. Small systems merge with other small systems. Gravity keeps gathering, sorting, folding, and building. The cosmos starts learning how to organize its light. This is where galaxies begin to emerge, not as perfect finished spirals drifting into view like they have arrived from a very expensive screensaver, but as messy, active, growing collections of stars and gas inside invisible halos of dark matter. The first galaxies are not polished. They are young, irregular, busy. They are places where matter is still arriving, stars are still forming, and gravity is still negotiating the final arrangement. That is one of the most soothing facts about the universe. Its beauty is not planned in advance. Nobody draws a neat diagram and hands it to space with a note saying, "Please swirl elegantly by Thursday." Order appears because the laws of nature keep acting over time. Gravity gathers matter. Gas cools and falls inward. Stars form. Systems merge. Structure grows. The universe does not need a blueprint to become breathtaking. Dark matter remains crucial here, even though it still refuses to be visually cooperative. It creates much of the hidden scaffolding in which galaxies form. Ordinary matter falls into those gravitational wells, collects, heats, cools, and slowly settles. You can think of dark matter as the quiet architect nobody can directly see, the one never asking for credit, never posting progress updates, just holding the whole project together with relentless gravity. As these halos of matter grow, the gas inside them does something graceful. It does not simply drop straight to the center and stop. It often carries angular momentum, that wonderfully stubborn property that keeps things rotating. So as gas falls inward, it can flatten into spinning structures. Not always immediately, not always neatly, and certainly not without interruptions, but the seeds of rotating galaxies begin to appear. Motion shapes form. This is the beginning of one of the loveliest patterns in the cosmos. A cloud gathers, falls, spins, compresses, and out of that process comes a system so vast that light takes tens or hundreds of thousands of years to cross it. Billions of stars can belong to one galaxy. Billions. Even saying the number does not really help. Human language was not built for this scale. A galaxy is less like an object and more like a whole nation of light held together by gravity. The earliest galaxies are likely quite different from many of the calm, well-formed spirals people know from photographs. They're often smaller, denser, more chaotic, more actively forming stars. They collide and merge often because the young universe is more crowded in a meaningful sense. Structures are closer together. Growth is fast. The cosmos is still in its eager building phase, and gravity has no problem with a little rough construction. Collisions sound violent, and in some ways they are, but on the scale of stars, galaxies are mostly spacious. When galaxies merge, individual stars usually do not smash into each other like billiard balls in a very dramatic documentary. There is simply too much room between them. Instead, gravity reshapes the whole systems. Gas clouds compress. New waves of star formation can ignite. Orbits change. Structures stretch and fold. Two galaxies meet, and over time they become one new thing. That is such a strange and beautiful idea. Galaxies grow not only by quiet accumulation, but by meeting other galaxies and changing form together. The universe builds magnificence through interaction. Even on the largest scales, becoming is collaborative. And slowly, through many such processes, the young cosmos begins to show recognizable patterns. Some galaxies grow into rotating disks, where stars and gas orbit in broad, flattened planes. Others become more rounded or elliptical, shaped by mergers and by the complex history of how they formed. Some remain irregular, full of clumps and knots and restless activity. The universe does not choose one shape and repeat it like a board decorator. It allows variety. Still, there's a special calm in the spiral galaxies that will come to dominate so much of human imagination. A spiral galaxy looks almost impossibly composed, with arms curving outward from a brighter center, stars and gas tracing elegant lanes through darkness. But those arms are not fixed solid structures like the blades of a fan. They are more like waves or patterns moving through the disk, regions where stars and gas bunch more densely as they orbit. The result is a design that feels intentional even though no intention is required. That may be the deepest comfort in cosmic structure. Beauty does not need permission. It can emerge from law, motion, and time. And galaxies do not form alone. They gather into larger communities. Gravity, still doing its patient work with almost irritating consistency, pulls galaxies toward one another into groups and clusters. Some systems remain relatively modest, a few galaxies bound together. Others become enormous clusters containing hundreds or even thousands of galaxies, all embedded in gigantic halos of dark matter and hot gas. The universe keeps scaling up its architecture. So you begin with tiny density ripples in the early glow. Those become denser patches of matter. Those patches help produce the first stars. Those stars gather inside young galaxies. Those galaxies merge and grow. Those galaxies collect into clusters. The pattern is astonishingly coherent. The cosmos starts with little differences and ends up building cities of light. And between those cities lie enormous stretches of relative emptiness. Not complete emptiness, never that simple, but vast cosmic voids where matter is sparse compared with the denser regions. On the largest scales, the universe forms something like a web, filaments of galaxies and dark matter stretching across unimaginable distances, intersecting at clusters, with huge, emptier regions between them. It is called the cosmic web, which sounds almost too poetic to be scientific, but there it is. Reality occasionally has excellent branding. The cosmic web is one of the grandest sights the human mind has ever inferred. Not seen directly with naked eyes, of course, because that would require eyes far larger than anyone could reasonably wear, but mapped, measured, reconstructed, and understood through careful observation. Matter in the universe is not sprinkled randomly like sugar on a table. It is structured into a vast connected network, shaped by gravity acting on those ancient ripples over billions of years. That means the present-day large-scale universe still remembers its beginning. The early fluctuations were tiny, but they were enough. Gravity amplified them. Expansion gave them room. Time did the rest. The grand web of galaxies is the grown-up version of the baby universe's slight unevenness. A tiny difference, given enough time, becomes architecture. There's a quiet lesson in that. Great structure can come from almost nothing more than persistence acting on a small asymmetry. The early universe did not need huge dramatic lumps to create galaxies and clusters. It only needed tiny variations and an extraordinary amount of time. Nature is patient enough to turn whispers into continents of light. As galaxies grow, Their interiors become more complex too. Dense central regions develop. Some galaxies form bulges packed with older stars. Disks rotate around them. Clouds of gas continue forming new stars in some places while other regions grow more quiet. Massive black holes may begin to occupy galactic centers, feeding on infalling matter at times and releasing astonishing energy. The universe is no longer merely making stars. It is making systems with histories, and histories matter. One galaxy may be calm and slowly rotating, shaped by long, steady growth. Another may be battered by mergers, puffed into a more rounded form. Another may still be furiously making stars from fresh gas. Another may be starved of gas and aging into relative quiet. Galaxies are not identical units. They are biographies written in gravity and light. That is part of why the universe feels so alive on these scales. Not alive in the biological sense, of course, but alive in the sense of having development, memory, and character. A galaxy is not just a shape. It is the visible record of everything that has happened to it. And yet for all this complexity, the large-scale picture remains deeply calm. Gravity pulls, matter gathers, rotation shapes, mergers transform, clusters assemble. The cosmic web stretches across space. No panique, no central command, no cosmic project manager frantically moving stars from one spreadsheet column to another. Just laws, time, and the astonishing willingness of matter to organize under those laws into something that looks almost artistic. This is where magnificence really starts becoming visible. The first stars were like single lanterns in a dark field. Galaxies are entire illuminated landscapes. They hold billions of stars, dark dust lanes, glowing gas, ancient stellar populations, newborn clusters, and long rotating structure. A galaxy is what happens when the universe decides one light at a time is no longer enough. Still, even now, the universe remains mostly spacious. Galaxies are separated by huge distances. Clusters are separated by even larger ones. Space is not crowded in the ordinary sense. Grandeur here comes not from squeezing everything close, but from arranging vastness in a pattern. That may be why galaxies feel so majestic. They are islands of form in an ocean of openness. And each galaxy is also a promise. Once galaxies exist, they provide stable homes for many generations of stars. Stars are born, live, die, and enrich the gas around them. New stars form from that enriched material. Over time, galactic environments become more chemically varied, more capable of producing planets, and all the later complexity that still lies ahead. The galaxy becomes the long-term setting in which cosmic history can deepen. But even without looking that far ahead, there is enough wonder here already. The universe began in a state so simple and extreme that nothing like a galaxy could possibly have existed. Then expansion cooled it. Tiny ripples survived. Gravity amplified them. Darkness waited. First stars ignited. And now, across the growing cosmos, entire systems of stars are finding shape, gathering into webs and clusters vast enough to humble any imagination, all without a blueprint. That phrase matters because humans are so tempted to assume that order must be imposed from outside. If something is beautiful, someone must have arranged it. If something is structured, someone must have drawn the plan. But galaxies show another possibility. Order can emerge from the inside, from law and interaction and patience. Not a random mess magically becoming perfect, but a lawful universe discovering form through time. So the cosmos keeps building. Young galaxies merge and mature. Rotating disks become more defined in some places. Great elliptical systems emerge in others. Clusters gather at the nodes of the cosmic web. The universe begins to look less like scattered lights and more like an immense connected civilization of stars, though no civilization yet exists to notice. You can almost feel the scale of it spreading around you now. No longer just isolated first suns, but galaxies turning slowly in the dark, clusters binding them together, filaments threading across the universe like luminous rivers, vast voids opening between them, everything shaped by old ripples and the unwavering pull of gravity. The cosmos has learned how to organize its light, and in doing so it has become more majestic than the early darkness could have hinted. And once galaxies begin holding generation after generation of stars, the universe starts doing something even more intimate than building grand structure. It begins changing the actual substance of reality in ways that will matter far more personally to you someday. Until this point, the cosmos has already achieved a great deal. It has made space, expansion, ancient light, darkness, first stars, growing galaxies, clusters, and the immense web of structure. Very impressive for a universe that began without a blueprint. But in terms of chemistry, it is still relatively plain. Hydrogen and helium still dominate. The heavier elements exist only where stars have begun making them. This is where stardust gets ambitious. A star is not just a light in the dark. It is a place where the universe experiments with pressure and heat so extreme that matter can be remade. Deep in a star's core, gravity pushes inward with merciless determination. The gas is compressed so fiercely that atomic nuclei can get close enough to fuse. That fusion releases energy, which is why stars shine, but the shining is only part of the story. The deeper story is transformation. Stars are where the universe learns how to become more chemically interesting than it was at birth. At first, most stars begin with the simplest job. They fuse hydrogen into helium. It is a modest beginning, but it is the foundation of everything that follows. Over time, in stars massive enough and hot enough, helium can fuse into heavier elements. Carbon appears, oxygen appears, neon, magnesium, silicon, sulfur, and eventually iron can be built in the hearts of the largest stars. The exact path depends on the star's mass, its internal structure, and how its life unfolds. But the principle is breathtakingly simple. Stars take the plain ingredients of the early universe and turn them into the elements needed for future complexity. That means every heavier atom around you has a history of pressure and fire behind it. Carbon was not present in abundance at the beginning of the universe. Oxygen was not waiting around in neat little bottles for oceans to happen later. Iron was not stacked politely in cosmic storage units. These things had to be made. The universe had to forge them. There is something deeply comforting in that. Complexity is not an accident tacked onto a simple cosmos. It grows out of the cosmos through a lawful, patient process. Stars are the workshops where that growth happens. They do not merely illuminate the universe. They enrich it, and the enrichment is not abstract. It is not just for distant nebulae and pretty astronomical posters. Carbon will one day become part of living chemistry. Oxygen will become part of water and breath and stone. Calcium will become bones and shells. Silicon will become rocks and sand and glass. Iron will become planetary cores, metal tools, red blood cells, train tracks, bridges, frying pans, and all kinds of gloriously ordinary things that never stop to thank a star for their existence. The universe starts simple, but stars refuse to keep it that way. Inside a massive star, this transformation happens in stages. As hydrogen in the core is used up, the star changes. Gravity presses inward more strongly. Temperatures rise. New kinds of fusion become possible. Helium can begin fusing into carbon. In more massive stars, the core grows hotter still, and other layers of fusion ignite in turn. The star develops an internal structure like nested zones, each one handling a different stage of nuclear burning. It is less like a simple lamp and more like a cathedral furnace with hidden chambers. This gives stars an almost architectural beauty. They are not featureless balls of fire. They have internal lives. They age. They change. They move through stages, balancing gravity against energy generation with astonishing delicacy. A star's glow can look serene from a distance, but inside it, matter is being forced into new identities. And yet there is a limit. Iron is a kind of turning point in stellar fusion. Up to a certain stage, fusion can release energy and help support the star against gravity. But building heavier elements beyond iron in a star's core does not continue that same easy bargain. Iron is a problem for the star. A beautiful, elegant, deeply inconvenient problem. Once a massive star builds up too much iron in its core, the balance begins to fail. That failure leads to one of the most dramatic events in the universe, the supernova. For the most massive stars, the ending can come when the core collapses under gravity so suddenly and violently that the outer layers are blasted into space. A star that has spent its life holding itself up through fusion finally loses the battle. The core caves in. Enormous energy is released. The star explodes. Supernovas are among the great acts of cosmic generosity. That sounds odd because they are violent events on an astonishing scale, and anything standing nearby would have a very bad day in an extremely final way. But from the perspective of the universe as a whole, these explosions are how stars share what they have made. The newly forged elements are flung outward into interstellar space. Material that once lived deep inside a star is scattered across its galaxy. And during these explosive endings, conditions can become extreme enough to create even heavier elements than iron. Gold, uranium, and others require environments of extraordinary violence and density. Some of these come from supernovas, some from other spectacular events like neutron star collisions. But the message is the same. The universe has to work hard to make the rich periodic table you now take for granted. Nothing about your world is chemically trivial. The atoms around you are old, traveled, and earned. That is why the phrase, "we are made of stardust," survives all the way from science into poetry. It can be overused, of course. Humans do enjoy taking a beautiful scientific fact and repeating it until it starts sounding like something printed on a scented candle. But the phrase remains true because it points to something real and profound. The carbon in your cells, the oxygen you breathe, the calcium in your teeth, the iron in your blood, all of these were forged in stars or in stellar catastrophes related to them. Your body is not metaphorically connected to cosmic history. It is materially connected to it. And the same is true for the non-living world. Mountains are stardust shaped by geology. Oceans are stardust arranged by chemistry and gravity. Sand is stardust weathered into grains. Your phone, your table, your window, the cup beside you, the dust on the shelf you noticed last week and nobly decided was a problem for future you, all of it comes from atoms forged in long-dead stars. This is where the grandeur of the universe becomes startlingly local. The stars are not just above you. In a deep sense, they're within everything around you. A galaxy is not simply a collection of lights in the sky. It is a machine for making material richness across time. That richness does not appear all at once. One generation of stars enriches the surrounding gas a little. Later stars form from that slightly enriched gas and can follow different paths because the chemistry has changed. Gas clouds cool more effectively when they contain heavier elements. Dust grains can form. Smaller stars become easier to produce in larger numbers. Planets become more possible. Each generation inherits the work of earlier stars and adds something new. So the history of a galaxy is also a history of increasing chemical sophistication. First stars live and die. Their ashes mix with interstellar gas. New stars form from that enriched material. More elements are made, more dust spreads, more possibilities open. Over billions of years, the universe becomes less simple and more capable. There is such tenderness in that progression. Complexity does not arrive in a rush. It is layered into existence through repeated acts of stellar life and death. The cosmos learns by generations. One star's ending becomes another star's beginning. One cloud's collapse carries the memory of ancient explosions. The universe keeps recycling matter until the conditions for something as intricate as a rocky planet or as delicate as a living cell become possible. And that means a calm night on Earth is the late result of endless earlier furnaces. Think of the things you barely notice in ordinary life. The oxygen around you, the calcium in a seashell, the iron railing outside an old building, the phosphorus in living tissue, the silicon in a pane of glass with rain sliding down it. These are not side details. They're the late bloom of cosmic history. The early universe could not provide them directly. Stars had to labor for them. There's something almost moving about how little the universe begins with and how much it eventually becomes. Hydrogen and helium sound like the setup for a very sparse existence, and for a while they are. But given stars, galaxies, and time, those simple beginnings open into abundance. Matter grows more expressive. The periodic table becomes a story of long patience and recurring fire. And stars are not the only part of the scene. The material they shed into space often mixes into great clouds of gas and dust, the raw material for future star systems. Dust matters more than the name suggests. Cosmic dust sounds like a nuisance, something you would wipe from a shelf while muttering. But in space, dust grains are important. They help cool clouds. They provide surfaces where molecules can form. They become part of the disks around young stars where planets may eventually take shape. Dust is what happens when the universe gets practical. Clouds enriched by earlier stars can collapse into new stellar nurseries. Inside those nurseries, young stars form surrounded by spinning disks. In those disks, grains collide, stick, grow, and begin the long process that can lead to rocks, planetesimals, and eventually full planets. This is still ahead in the larger story, but the path begins here, with stars manufacturing the elements and then returning them to space. Without this enrichment, there are no rocky worlds, no landscapes, no minerals, no water chemistry as you know it, no bodies, no biology. A universe of only hydrogen and helium can be grand, but it cannot become intimate in the way your world is intimate. It cannot make forests, bones, river stones, coral reefs, lungs, or candles. For that, the universe needs stars to get ambitious. And stars do. They make carbon, the backbone of life as you know it. They make oxygen, which pairs with hydrogen to form water and binds into so many minerals. They make silicon, which helps build rocky planets. They make magnesium and sulfur and calcium. They create iron, which will settle into planetary cores and help worlds generate magnetic fields. They create the vocabulary of solid things. They turn a young, simple universe into one capable of texture. That word matters. Texture. The early cosmos is magnificent but chemically smooth. Later cosmos has texture. Stone has texture. Bark has texture. Bone has texture. Clouds have texture. Skin has texture. Dust on a windowsill has texture, even if it is a rude reminder that entropy never takes a day off. Stars are the reason the universe can eventually feel physically rich instead of chemically bare. This is also where the story becomes quietly personal in an almost absurd way. The iron in your blood exists because ancient stars once fused lighter elements into heavier ones and then returned them to space. Every time your heart moves blood through your body, it is relying on an element forged in stellar interiors. A star had to live and die for that to be possible. Not for you specifically, of course. The universe was not taking custom orders. But still, the connection is real. You are not just living under the universe. You are participating in its chemical afterlife. And the same goes for every ordinary scene you love. A shoreline at dusk, bread on a wooden table, rainwater running across pavement, a sleeping dog, a ceramic mug warming your hands. These things feel close, domestic, immediate. Yet every one of them depends on a universe that learned how to forge heavier elements across generations of stars. The ordinary world is made possible by extraordinary history. So the galaxies that found their shape in the previous stretch are not just collections of lights turning in darkness. They're nurseries, archives, and recycling systems for matter itself. Stars are born inside them, live out their luminous negotiations with gravity, manufacture new elements, and then return enriched material to the interstellar medium. A galaxy slowly teaches itself chemistry, and chemistry, over time, teaches the universe how to become habitable. That is why this stage feels so majestic. The cosmos is no longer merely arranging matter into larger structures. It is changing what matter can be. It is producing the ingredients for mountains, clouds, oceans, coral, blood, snow, teeth, leaves, glass, and all the other textures of a richly material world. The first stars lit the darkness. Their descendants begin furnishing existence. And through all of this, there is still no rush. Billions of years pass. Stars live and die. Gas clouds enrich and collapse again. Galaxies keep evolving. The universe keeps layering complexity upon complexity, not by hurrying, but by repeating deep patterns across astonishing spans of time. Fusion, release, mixing, renewal. The cosmos works like a patient artist with an unlimited deadline. By the time later worlds begin forming in earnest, the ingredients are there because stars have spent ages making them. The universe has gone from simple light elements to a much richer chemistry, from featureless gas to the possibility of stone and sea. Stardust has become ambitious enough to build worlds. And that is the quiet miracle resting underneath everything familiar. The bones in your body, the oxygen in your breath, the minerals in the ground, the salt in the ocean, the metal in a spoon, the glass in a window catching late light, all of it began as the work of stars that burned before your world existed. The universe learned how to make more than light. It learned how to make substance. It learned how to make the materials of nearness, the matter of touch, the ingredients of home. By this point, the universe has already done enough to make any reasonable mind sit down for a minute. It has begun in a state beyond ordinary imagination, expanded, cooled, released its first light, waded through a long darkness, made stars, built galaxies, and allowed those stars to manufacture the ingredients for future worlds. That would already be an outrageously beautiful story. But the deeper you look, the more the universe quietly reveals that it is not only grand. It is weird, not sloppy weird, not random weird, elegant weird. This is where the cosmos becomes even more fascinating because the visible universe, the part made of stars and gas and dust and planets and all the solid, glowing, breathable things people tend to get emotionally attached to, turns out to be only a fraction of the whole story. The universe keeps secrets. Some of them are not small. Take dark matter. The name sounds dramatic, which is helpful because the concept is dramatic. For a long time, astronomers studying galaxies noticed something odd. Stars and galaxies were moving in ways that did not quite fit the amount of visible matter present. If you added up the stars, the glowing gas, the dust, all the stuff you could actually detect in the ordinary sense, there still did not seem to be enough gravity to hold galaxies together the way they were behaving. They should have spun apart more easily, but they did not. So either gravity itself was wildly misbehaving on these scales, or there was extra matter there that could not be seen directly. The evidence kept stacking up. Galaxies inside clusters moved as if more mass was present than anyone could see. Light from distant objects bent around massive structures in ways that suggested hidden gravitational weight. The large-scale cosmic web, the way matter is organized across the universe, also made more sense if an invisible form of matter had helped shape it from early times. Again and again, the cosmos seemed to be saying the same thing in its patient, statistical way. There is more here than your eyes can find. That is one of the most soothing scientific ideas, strangely enough. The universe is not only what is obvious. It has depth. It has hidden structure. It contains realities that announce themselves indirectly, not by shining, but by pulling. Dark matter does not seem to emit light, absorb light, or scatter light in the usual ways. It is not invisible in the casual sense, like a black cat hiding in a dark room and feeling very pleased with itself. It is invisible because it appears to interact very weakly, if at all, with electromagnetic radiation. Light mostly ignores it, but gravity does not. Gravity keeps the receipts. And that is why dark matter matters so much to the birth and growth of the universe. Long before galaxies became beautiful in a way cameras can admire, dark matter was helping shape the stage. Those tiny ripples in the early universe grew under gravity, and dark matter, being abundant and not slowed down by light in the same way ordinary matter was, could begin gathering into structures early on. It formed the hidden scaffolding into which normal matter later fell. Stars and galaxies grew inside this invisible architecture, which means that some of the most magnificent things in the universe may owe their shape to something we still do not understand fully. That is just wonderful. Slightly rude, perhaps, but wonderful. Dark matter is one of the best reminders that science is not a collection of final answers. It is a relationship with reality. We observe, we infer, we test, we refine. We say, very calmly, the universe appears to contain a great deal of matter that does not behave like the matter we know. We do not yet know exactly what it is. That is not weakness. That is discipline. There are ideas, of course. Maybe dark matter is made of some new kind of particle. Maybe it is part of physics not yet discovered in the laboratory. Maybe several possibilities are still alive, but the exact identity remains unsettled. So the universe gives us this extraordinary combination of certainty and mystery. We are highly confident that something real is there, shaping galaxies and clusters and the growth of structure. But we are not yet holding it neatly in our hands. And then, as if hidden matter were not enough, the universe goes one step further and reveals that its expansion is not merely continuing. It is accelerating. This is where dark energy enters the story, and the story becomes even stranger. For a long time, you might naturally assume that after the Big Bang, the universe would keep expanding, but gravity would gradually slow that expansion down. After all, gravity pulls things together. It makes intuitive sense. The cosmos flies outward, gravity tugs back. Expansion continues, but loses a bit of momentum over time. A sensible picture. Very tidy. The universe, however, has never shown much commitment to being tidy in ways that make human expectations comfortable. When astronomers studied certain distant exploding stars called Type Ia supernovas, they found evidence that the expansion of the universe was speeding up, not slowing down. Distant galaxies were receding in a way that suggested space itself is expanding faster and faster over time. Not because galaxies are pushing one another away through some cosmic traffic dispute, but because the fabric of space is stretching under the influence of something that acts like a kind of repulsive effect on the largest scales. That something is called dark energy. Again, the name is honest in the most minimalist way possible. It basically means there appears to be some mysterious component affecting the expansion of the universe, and we do not yet fully know what it is. Scientists are not trying to sound dramatic here. They're trying not to lie. Dark energy seems to make up an enormous portion of the cosmos, which is almost funny if your sense of humor includes being humbled by reality. The ordinary matter that makes stars, galaxies, planets, cats, coffee, bones, sea salt, libraries, and all the rest is only a small part of the full cosmic inventory. Much of the universe appears to be dark matter and dark energy, both deeply important and not directly understood in the comfortable, everyday sense. So the visible world, the thing that feels so solid and immediate to you, is not the whole story. It is more like the illuminated front room of a much larger house. That does not make your world less real. It makes it more astonishing. The familiar exists inside the unfamiliar. The understandable floats in a larger sea of mystery. You're made of ordinary matter, yes, but ordinary matter itself turns out to be the minority in a universe shaped by stranger influences. Dark energy is especially haunting because it affects the fate of everything on the largest scales. If the expansion of the universe keeps accelerating, then over immense stretches of time, distant galaxies will recede farther and farther away. Space between large structures will grow more and more. The night sky of the far future, at least from the perspective of any surviving observers in a long-lived galaxy, could become lonelier, more isolated. The visible universe would shrink in a practical sense, not because it gets smaller, but because more of it slips beyond reach. And still, even here, the strange rule is not chaos. It is order we do not yet fully grasp. The universe is doing something consistent. Dark energy is not randomly speeding up expansion one afternoon and then taking the weekend off. It behaves with large-scale regularity. The mystery lies not in whether it is there, but in what it is. Some scientists connect dark energy with the energy of empty space itself. That phrase alone is enough to make your brain sit very still for a moment. Empty space may not be truly empty. Even a vacuum, in modern physics, is not simple nothingness. It can have properties, structure, fluctuations, a kind of restless baseline existence that refuses to become the absolute blankness human intuition keeps begging for. The universe seems incapable of being that simple, and that weirdness runs deeper still. The laws beneath matter and light are themselves full of strange elegance. Quantum physics, the theory describing the smallest scales, give a world where particles behave in ways that do not line up neatly with common sense. They can act like waves and particles. Outcomes are described in terms of probabilities. Empty space is active in subtle ways. Tiny fluctuations in the early universe may have helped seed the structure of everything that came later. The vast cosmic web may ultimately trace its ancestry to quantum whispers stretched across the young universe during inflation that is almost too beautiful to hold in one thought. The largest structures in existence may owe part of their origin to the smallest restless behaviors in the early cosmos. Galaxies, clusters, and filaments may carry the amplified memory of microscopic uncertainty. The universe is stitched together across scale in ways that feel almost poetic, except poetry would probably struggle to be this precise. Even time and space themselves, the things that feel most basic, turn out to be less fixed and obvious than they seem. Relativity teaches that time can stretch, that gravity shapes space-time, that motion changes how duration and distance are measured. The universe is not built on a rigid stage. The stage bends. The clock is part of the play. And somehow, despite all this strangeness, the cosmos remains lawful enough that beings like you can exist inside it and gradually understand some of it. That may be the most miraculous part. The universe is not obligated to be intelligible. It could have been a blur of inconsistency, an unknowable mess of disconnected events. Instead, it is strange, yes, but strange in a way that invites understanding. It hides things, but it leaves clues. It exceeds intuition, but it rewards patience. That is why mystery in science feels different from mystery in superstition. Scientific mystery is not a decorative fog. It is a frontier with shape. We know where the questions are. We know some of the behavior. We know dark matter pulls. We know dark energy affects expansion. We know the visible cosmos is only part of the whole. We know the laws of the very small and the very large are both astonishing. We also know there are gaps. Clean, honest gaps. And those gaps make the universe feel alive with possibility. There is such peace in admitting that the cosmos remains partly unknown. It means wonder is not a temporary phase that disappears once facts arrive. The facts deepen the wonder. The more you learn, the larger the edges of mystery become. A child looks at the sky and feels, all because the stars are bright and distant. A scientist looks at the sky and feels, because the stars are only a fraction of what is there. So the universe carries on under strange rules. Visible galaxies turn inside invisible halos. Cosmic structure grows with help from matter I can detect. The expansion of space accelerates for reasons not yet fully pinned down. Quantum fluctuations in the very early universe may echo in the grand distribution of galaxies across billions of light years. Space is not simple emptiness. Time is not an independent universal metronome. The obvious world floats inside deeper layers of law and mystery. And the remarkable thing is that none of this makes the universe feel cold. If anything, it makes it feel more textured, more alive, more layered. Reality is not exhausted by what is immediately seen. It keeps depth in reserve. It keeps whole chapters hidden beneath the visible surface. The stars and galaxies are beautiful, but they are also clues, signs of a deeper structure still waiting to be understood. You live in a universe that is not only vast but subtle. A universe where the visible is carried by the invisible, where the familiar depends on the mysterious, where the largest things remember the smallest beginnings, and where the rules are strange enough to humble anyone, yet steady enough to trust. That is not a flaw in the story. That is the story becoming even more magnificent than it first appeared. And once you understand that the universe is built on both visible beauty and hidden rules, something quietly shifts in the way you see yourself inside it. The story stops feeling like a documentary happening at a safe distance. It stops being only about ancient stars, remote galaxies, and forces so large they seem to have nothing to do with the softness of your blanket or the slow rise and fall of your breathing. The distance begins to close. Because the most intimate fact in all of this is that you are not standing outside the universe, admiring it like a tourist in a very large museum. You are inside the process. You are one of the late results. That is not a metaphor. It is not a sentimental line added to make the science feel warm. It is a material truth. The atoms in your body have a history. The carbon in you is made in stars. The oxygen in you is made in stars. The calcium in you, the iron in you, the nitrogen in you, all of it comes from a universe that spent billions of years becoming capable of such things. You are not separate from cosmic history. You are assembled from it. And that makes your existence feel both smaller and more meaningful at the same time, which is one of the universe's favorite tricks. It humbles you and includes you in the same motion. You begin with the early universe, where there's almost nothing but hydrogen and helium. Then stars form, shine, and make heavier elements. Those stars live and die, returning enriched material to space. New stars form from that changed material. Galaxies keep evolving. Planetary systems begin to appear around later generations of stars. Rocky worlds become possible because earlier stars did the hard labor of element making. Oceans become possible because chemistry has deepened. Atmospheres become possible. Complex molecules become possible. Little by little, through time so vast, it almost stops feeling like time. The universe becomes a place where one small planet can exist with liquid water on its surface. That planet is not inevitable in the dramatic movie sense. There is no giant finger pointing at one future Earth from the beginning and saying, yes, that one. But neither is it magic. It is the result of lawful processes playing out across immense spans of time. A suitable star, a protoplanetary disk rich enough in heavy elements. Worlds colliding, gathering, heating, cooling. Water arriving or forming. Chemistry deepening. Conditions stabilizing enough for life to persist. The path is long, but is still a path. And on one such world, chemistry becomes more than chemistry. It becomes biology. This is one of the strangest turns in the entire story. The universe spends billions of years making stars and galaxies and atoms and planets. And then on at least one small world, some of those atoms organize into living systems that can grow, repair themselves, reproduce, sense their surroundings, and eventually wonder where they came from. Matter does not stop at forming rocks and oceans. In at least one corner of reality, it becomes curious. That is an astonishing sentence to be able to say. Matter becomes curious. Your body is a temporary arrangement of ancient atoms held together by ongoing biological processes. That sounds very clinical at first. Maybe not the kind of thing you stitch onto a pillow, but stay with it. Those atoms have traveled through stars, explosions, clouds of gas, planetary formation, geologic change, water cycles, food chains, and living history before arriving in you. Some of the atoms you carry may once have been in stone, in seawater, in leaves, in creatures long gone, in ancient air, in other living bodies, in the dust of places no human recorded. Matter circulates. Life borrows it for a while. There is something deeply peaceful about that borrowing. You're not a thing dropped into the universe from elsewhere. You're made from the same inventory as the stars and the sea. Your body is not a foreign object in reality. It is one of reality's own local arrangements, one very specific way the universe has taken shape for a little while. And if that sounds like it makes you too small, it helps to notice the other side of it. The universe is not only around you. It is within you in a literal chemical sense. The iron in your blood is old. The calcium in your bones is old. The oxygen you are breathing right now was forged long before your species existed. You're ancient material doing something very recent. That is such a lovely balance. Old matter, new experience. It also changes the way you think about scale. People often imagine the cosmic and the personal as opposites. The universe is vast. Your life is tiny. End of story. But the truth is more interesting than that. Your life is tiny in duration compared with cosmic time. Yes. Your body is tiny in size compared with galaxies, obviously. You are not larger than the Andromeda Galaxy, no matter how good your week has been. But significance is not measured only by size. A thought is small in size too. So is a heartbeat. So is a memory. Small things can still matter because of what they are, not because of how much space they take up. And what you are is extraordinary. You are a part of the universe, able to become aware of the universe. Out of all the blind processes that built stars and galaxies and planets, there arose at least one creature capable of looking up and asking what any of this means. That does not place you above the cosmos. It places you among its most intricate results. For billions of years, the universe expanded and cooled whether anybody noticed or not. Stars lived and died without applause. Galaxies merged in darkness. The cosmic web stretched itself out in silence. Then eventually, on one small world, matter arranged itself into brains that could model reality, imagine the past, predict the future, invent language, build telescopes, write equations, and tell bedtime stories about the birth of the universe. That is not a side detail. That is one of the most amazing developments in the entire known story. And it happened using the same atoms that were once inside stars. You can feel the nearness of that if you want to. Not in some mystical, hand-wavy way, but in a grounded physical way. When you inhale, oxygen enters your lungs and moves into your blood. That oxygen was forged in stellar interiors. The iron in your red blood cells, also made in ancient stars, helps carry it. So every breath is a meeting between two kinds of stardust that have found themselves briefly cooperating inside a living body on a rocky planet. If the universe had a sense of theater, that would be one of its better scenes. And then there is the brain, a soft, electrically active organ made of ordinary matter, following physical laws, and yet somehow capable of experience, capable of hearing these words, forming images, feeling wonder, remembering, imagining. Science can tell you a great deal about neurons, signals, networks, and evolution, and still the existence of conscious experience remains one of the most profound facts in the universe. The cosmos did not only produce structure and chemistry, it produced inner life. You lying there, listening, are part of that miracle. The universe is not only happening out there in the dark above your house. It is happening in the fact that you can know you exist at all. That recognition does something gentle to loneliness. Not because it removes loneliness completely. Human feelings are rarely that cooperative, but it changes the frame. You are not a detached little mind trapped in a meaningless corner. You are continuous with the whole story. Your body comes from the Earth, which comes from stellar material, which comes from earlier cosmic history, which comes from the long unfolding of the universe itself. You belong here in the deepest possible physical sense. Belonging does not mean permanence. This is where the story stays honest. You are temporary. Every living thing is temporary. Stars are temporary. Galaxies change too. The universe does not promise individual permanence to anything within it. But temporary does not mean accidental in the trivial sense. A song is temporary. So is dawn. So there's a conversation that matters. The value of something is not canceled by the fact that it does not last forever. In a strange way, the temporary nature of life makes its belonging even more beautiful. The atoms circulate through forms. They spend a while as part of stars, a while in gas clouds, a while in planets, a while in living creatures. The universe keeps rearranging itself. Life is one of those arrangements. You are one of those arrangements. Brief, yes, but real. And because you are real, your ordinary life becomes part of cosmic history too. Not on the scale of galaxy clusters, perhaps. The Milky Way is not adjusting its spiral arms because you finally answered that awkward message. But still, your life is not outside the universe's story. Every meal, every walk, every laugh in a kitchen, every quiet grief, every tired evening, every act of care, all of it takes place inside the same cosmos that began in that hot, dense state and unfolded through stars and galaxies to reach this moment. The universe did not stop being majestic when it became personal. It became more so. A glass of water, for example, stops looking ordinary once you think about what it really is. Hydrogen from the early universe. Oxygen forged later in stars. Bound together on a rocky planet around a middle-aged star in the outskirts of galaxy among billions of galaxies. That is what is sitting quietly in a cup. Water is cosmology you can hold. The same goes for the ground beneath you. The silicon in rock, the iron deep in Earth's core, the carbon cycling through living things, the calcium in shells and bones, the sodium in the sea, all of it is matter with a past. Earth is not separate from the universe either. It is what the universe looks like here after enough time has passed. And you're what the universe looks like when Earth's chemistry begins to think. That line may sound grand, but it is simply an honest description. Conscious life is one of the ways the cosmos has expressed itself, at least in this known corner. You do not need to be large to carry that significance. You only need to be real. This is why learning about the universe can be so calming. It does not reduce you to nothing. It relocates you from the center to the fabric. That is better. The center is lonely and unrealistic. The fabric is shared. You are woven into something older and larger than your worries, but not erased by it. Your stresses remain real. Your hopes remain real. Your life remains particular and unrepeatable. Yet all of it exists inside a continuity that reaches back to the first moments of cosmic history. So when you look up at the night sky, you are not seeing a foreign realm. You're seeing relatives of a kind, not relatives with whom you would split rent, because that arrangement would be very difficult, but kin in substance and origin. The stars above and the atoms within you belong to the same unfolding. The separation between you and the cosmos is much thinner than it first appears. And perhaps that is the most relaxing fact of all in this part of the story. The universe is vast enough to humble you, strange enough to amaze you, and intimate enough to include you. It made stars, and then used the ashes of stars to make worlds. It made worlds, and then, on at least one of them, life. It made life, and then, in time, beings who could lie awake in the dark and listen to the story of the beginning, hearing in it not only distance and grandeur, but also home. And because it can feel like home, The future of the universe feels less like a distant science diagram and more like the far end of a story you already belong to. The same cosmos that made atoms, stars, galaxies, oceans, and listening minds will keep going. It does not stop with your moment, or with Earth, or with the age of bright, familiar skies. The universe is still unfolding, and one of the most relaxing things about that future is how slowly it happens. The dramatic eras, in a way, are already behind us. The beginning was intense. The first stars were bold. Galaxies grew through collisions and restless formation. Heavy elements spread. Planetary systems emerged. Life appeared, at least here. These are the loud pages, cosmically speaking. The future, by comparison, is gentler, longer, more spacious. It has fewer fireworks and more fading. That is not sad in the simple sense. It is serene. For a very long time yet, stars will continue to shine. Not forever, but far beyond any timescale a human mind naturally carries around. Some stars live only millions of years. Others, especially small red dwarfs, can endure for trillions. Trillions. The word almost stops being a number and becomes weather. These little stars burn their fuel so slowly, so patiently, that they outlast brighter stars by astonishing margins. The universe, even in its older age, will not run out of light all at once. It will linger. That lingering matters. It means the cosmos does not rush towards silence. Bright blue giants may come and go quickly, but smaller stars hold the long watch. Their lives stretch onward through ages so vast that today's galaxies are only the early scenery. Around such stars, worlds may continue to orbit. Future planetary systems may still exist in quiet darkness lit by modest suns. The universe keeps some lamps on for an incredibly long time, but the pattern does change. Star formation will not continue forever at its current pace. Galaxies use up their cold gas, or heat it, or lose it. The easy raw material for making new stars gradually becomes harder to gather. Over immense stretches of time, galaxies become less fertile. They still contain stars, sometimes many of them, but fewer new ones are born. The universe grows older not by stopping suddenly, but by becoming less productive, less eager, more settled into what it has already made. You can hear the calm in that. The cosmos does not crash into old age. It drifts there. Galaxies themselves continue changing. Some merge, some stretch and reshape under gravity. The Milky Way and Andromeda, for example, are expected to meet far in the future, not as a catastrophic smash for individual stars, since there is too much room for that, but as a long gravitational dance that will eventually create a larger combined galaxy. Even giant systems do not remain fixed. They evolve, fold together, and take on new forms. Yet even these grand mergers are slow beyond ordinary imagination. The future is full of motion, but it is stately motion. So while stars age and galaxies transform, the expansion of the universe continues. And because of dark energy, that expansion appears to accelerate. Over enough time, distant galaxies will slip farther away from one another. Light from the most remote regions will become harder and harder to reach. The great cosmic web will not vanish, but its connected visibility will thin. If some far future civilization existed in a galaxy like ours, it might see a lonelier sky than we do, with more of the wider universe having receded beyond practical view. There is something haunting about that, but also something soft. The universe becomes more spacious still. Distance wins slowly. The grand communities of galaxies remain real, but each local region grows more isolated with time. The cosmos does not become violent. It becomes quiet. In the unimaginably far future, many of the bright stars we know and love will be gone. Massive stars will have long since burned out. Medium stars like the Sun will have completed their lives. Their endings differ depending on their mass. Some stars leave behind white dwarfs, dense ember-like remnants no longer powered by fusion. More massive stars may leave neutron stars, or black holes. These leftovers remain, cooling or persisting through vast spans of time, like the bones of stellar history. White dwarfs are especially poetic. A star like the Sun does not end in one final dramatic flash of identity. It sheds outer layers, leaves behind a hot, dense core, and that core cools slowly, unimaginably slowly, over time. A white dwarf is like a cosmic coal left from an earlier fire, a remnant holding heat long after fusion has ended. The future universe may contain immense numbers of such quiet remnants, not shining with the confidence of youth, but still existing, still cooling, still part of the story. Neutron stars are stranger still, matter compressed to astonishing density, objects so extreme that a spoonful of their material would outweigh mountains. Black holes, of course, remain among the most mysterious and dramatic leftovers of all, places where gravity bends space-time so deeply that the boundary around them becomes a point of no return. Yet even these are not outside the long calming arc of the universe's future. They too belong to the gradual thinning of active light. The age of stars gives way, very slowly, to an age of remnants. That phrase sounds bleak until you really sit with it. Remnants are not failures. They are memory made physical. A white dwarf is proof that a star once shone. A neutron star is proof that a giant once lived and ended. A black hole is not cosmic vandalism. It is one of the ways matter records an extreme past. The older universe may be quieter, yes, but it will still be full of history. And the timescales keep stretching. If proton decay happens, as some theories allow though it has never been observed, then ordinary matter itself may eventually dissolve over times beyond anything stars can survive. If it does not happen, some forms of matter may remain longer. Science is honest here. The very far future contains open questions. But even uncertainty has a shape. We know enough to see the broad tendency. The universe keeps expanding. Active star formation declines. Brightness becomes rarer. Energy spreads thinner. The cosmos moves toward greater emptiness, greater separation, greater calm. Even black holes, those great long-lived monuments of gravity, may not last forever. Through a subtle quantum process called Hawking radiation, black holes are expected to lose energy extremely slowly. For stellar mass black holes, and especially for supermassive black holes, this evaporation would take absurdly long spans of time, far longer than the current age of the universe by factors that make language blush and give up. But still, the principle is astonishing. Even the darkest, most durable objects may eventually fade. So the far future may become a universe of fading remnants, cooling leftovers, immense stretches of emptiness, and ever-widening space. Not a sudden end, more like a long dimming. This is often called heat death, though the name is gloomier than the feeling it actually invites. It does not mean fire. It means the opposite. A future state where energy differences have been smoothed out so much that there is little left to drive large, organized activity. No dramatic collapse, no final cosmic scream, just a universe approaching equilibrium, where usable energy is scarce and change becomes slow and sparse. And what a gentle ending that is, in its own strange way. The universe begins in unimaginable compression and heat, then spends eons unfolding into structure, light, chemistry, life, thought, and wonder, before gradually relaxing into wider and wider quiet. The whole story arches from intensity towards stillness. It is almost like a long exhale. That shape matters. It means the universe is not a tale of endless escalation. It does not build forever toward louder and louder acts. It blooms, it shines, it enriches, it astonishes, and then, over durations too large to fear personally, it softens. The future is not a cliff waiting at the edge of your life. It is an ancient process of gradual release. And within that process, your own moment becomes even more precious. You live in one of the luminous eras, An age where stars fill the sky, where galaxies are still visible across deep space, where heavy elements are abundant, where planets exist, where chemistry can bloom into life, where minds can arise and ask questions. You are here during the part of the universe that sings most clearly, not at the beginning's impossible heat, and not in the far future's enormous hush, but in the long, bright middle where complexity flowers. That is not a burden. It is a gift. It makes tonight feel a little different. The room around you, however ordinary it seems, exists in a rare kind of cosmos, one that has had enough time to make calm things. Enough time to make what glass, fabric, breath, memory, language, and the soft electric glow of a small light in a quiet house. Enough time to make someone who can lie still and imagine the birth and future of everything. Enough time to make tenderness. And tenderness is, in its own way, one of the universe's great late achievements. Because the early cosmos was not tender. It was too hot, too dense, too simple. Tenderness requires complexity. It requires bodies that can feel comfort, minds that can know rest, worlds that can cool, atmospheres that can soften light, beings that can care. All of that is late work. All of that belongs to a universe that has spent billions of years becoming subtle enough for gentleness. So when you think about the calm future of everything, it does not need to feel cold or bleak. It can feel complete. The universe does not fail by becoming quieter. It fulfills its long arc. It creates magnificence, then slowly lets magnificence rest. It creates worlds, then allows worlds to change. It lights stars, then lets their embers cool. It spreads matter into structure, then gradually loosens structure back towards spaciousness. The story does not end in panic. It ends in release. And perhaps that is why the birth of the universe can be so soothing to think about. Not because it was simple, and not because it answers every question, but because from beginning to end the cosmos is engaged in one continuous act of becoming. Hotter, cooler. Denser, wider. Dark, luminous, quiet again. It carries everything from first light to final hush within one astonishing motion. You are part of that motion for a little while. Not outside it, not beneath it, not forgotten by it. Part of it. A brief living arrangement of ancient matter, awake during one of the bright eras, able to know that the universe had a beginning and will have a future, able to feel small without being erased, able to belong without needing to own the whole sky. And that is enough. More than enough, really. So the future keeps opening beyond imagination. Stars continue for ages, then fewer remain. Galaxies age, distances grow, remnants cool. Even black holes may someday fade. Space keeps widening. The great story loosens into stillness. And through all of it, the universe remains what it has always been since the first instant we can meaningfully speak of, a place of law, mystery, patience, and grandeur, moving from impossible brightness toward a final, beautiful hush. The hush is very far away. Tonight, the stars are still here. The galaxies are still turning. The old afterglow still whispers through space. Matter still remembers ancient fire. And you, for this brief, miraculous moment, are here to know it. The room can be small. The story is not. You can let the scale of it ease your shoulders. You can let the age of it loosen the little knots of today. The universe has carried on through every phase by changing slowly, lawfully, beautifully. It has made room for light, for worlds, for life, for curiosity, and one day it will make room for silence too. There's nothing in that rhythm you need to resist tonight. So rest inside the long middle of things, where stars still shine and questions still glow, and the future is not a threat, but a distant softening. Rest inside a universe old enough to be wise with slowness. Rest inside the knowledge that everything began, everything changed, everything continues, and everything at the farthest edge will one day grow gentle. The sky above you does not need to explain itself any further. It has already told you enough. It began in mystery, bloomed into light, made the elements of your body, and will keep widening long after every busy thought of today has dissolved into something much quieter. You do not need to solve the whole cosmos to be comforted by it. You only need to remember that you are woven into its long, peaceful arc. And as the great future stretches onward beyond all counting, beyond stars, beyond remnants, beyond even the last dark monuments of gravity, the universe seems to do what it has been doing all along. It keeps letting go. It keeps opening. It keeps becoming still. So you can do the same. The dark can be kind. The scale can be kind. The silence can be kind. You are here, in the warm, bright interval between the first fire and the final hush, listening to the oldest story there is, and for this one small moment, that is a wonderfully peaceful place to be. The sky can widen above you. The galaxies can turn without asking anything of you. The ancient light can keep crossing space, and you can rest. The oldest beginning has already happened. The farthest ending is in no hurry. Between them lies this soft, brief island of awareness, this gentle human moment, this breath, this room, this listening. So let everything grow a little quieter. Let the universe be vast without becoming heavy. Let the future be distant without becoming frightening. Let your thoughts move more slowly, like dim stars crossing a wide winter sky. Untroubled, unchaste, each one taking its time. There's nothing you need to hold together right now. Gravity is doing its work. The stars are doing theirs. Space is widening exactly as it has for ages. The old afterglow still whispers from every direction. The great arc of reality is carrying on with magnificent patience, and you do not need to manage any of it tonight. You only need to be here. You only need this one small patch of quiet, this one body made of ancient elements, this one mind easing its grip, this one darkened room floating on a world that was built from stellar ash and cooled long enough to cradle life. Let that be enough. Let it be more than enough. The universe began in brilliance, wandered through darkness, made light again, filled itself with structure and chemistry and living things, and will one day fall into a hush so deep and spacious that even language can barely follow it there. But you do not have to travel to that far edge tonight. You can simply rest in the knowledge that the story is whole and beautiful and still unfolding gently around you. So the stars can remain where they are. The galaxies can keep their slow, ancient turning. The future can stay far away, soft and pale and patient. And you can drift here, held for a little while inside the long, calm memory of everything.